this video is going to cover how to factor when the situation is a difference of squares. And you're going to need to be able to recognize when that situation occurs, and so difference stands for subtraction and squares stands for perfect squares. The form will look like this: a squared minus b squared, and can be factored by doing a minus b times a plus b. Or it could be a plus b times a minus b. The order doesn't matter. But as long as you have a perfect square minus a perfect square, you will have a difference of squares situation that can be factored using that formula. And so let's take a look at one example. So example 1 here, we'll just say is x squared minus 1. Both are perfect squares. X squared is a perfect square and 1's a perfect square. And the way to figure out what would go in each parentheses, to figure that out, you would just square root each term. So x squared, when you square root it, is just x, and 1 square rooted is 1. So in each parentheses, we'll go x minus 1 and x plus 1. To check your answer, you could FOIL that back out, and then you would see that the ending result, after you multiply those two binomials together, would be x squared minus 1. But let's make it a little more exciting. So let's make it 100x squared minus 121. And so now it's got a lot of numbers going on in here, but to find a and b is going to be the same way. We're going to look at 100x squared, and we're going to square root it in our mind, and that would give us 10x. And then we'll look at 121 and square root that, and that'd give us 11. And so 10x minus 11, and then you do 10x plus 11, just like the formula says. The only other thing would be is if the order is a little different, that's okay. Alright, so maybe like 49 minus 16x squared. You can't change the order. I know a lot of people want to put the x squared first, but you would have to do a few extra steps if you wanted the x squared to be first. So it's best just to leave it this way for now, and in your mind square root 49, which would be, hopefully you thought of 7, and then if you square root 16x squared, that would be 4x. So 7 minus 4x and 7 plus 4x. I'm going to show one more problem just to add a little wrinkle into this. It's something we'll see next week, so for those of you who watch this video, you're welcome. So here it is. One problem may involve multiple steps, so here's this fourth and final example. It would be 50x squared minus 2. When you look at it, 50 is not a perfect square, neither is 2. However, there's a greatest common factor in it. So if you took out the GCF first, then you might see, right, and GCF is 2, both are divisible by 2. So if I take out 2, it would be 25x squared minus 1. And now when you look inside the parentheses, you actually see a difference of square situation. So the square root of 25x squared is 5x, and the square root of 1 is 1. And so this would factor to 5x minus 1 and 5x plus 1. And that 2 would remain in front. And so that would actually be fully factored. So that's it. That's difference of squares. Have a great day, and talk to you soon.